Nuclear. The name alone carries with it a heavy stigma of war and death, due in large parts to the destructive power of the nuclear bomb and the fear of mutually assured destruction during the Cold War. But the power of the atom has also brought about significant changes for the energy sector and has the potential to prevent a global energy crisis. Before that, it's important to know the basics of nuclear energy. There are two ways of generating power from atoms: fission and fusion. Fission is achieved by bombarding uranium-235 with neutrons in order to split it up and cause a chain reaction of fission, releasing vast amounts of heat. Fusion, the same process found in stars, is the opposite. Two atoms are crashed into each other to form a denser atom. In the case of attempted fusion reactors, two hydrogen atoms are collided to form helium and release even more energy than a fission reaction, approximately 7 times more energy per nucleon. Both processes still are very powerful reactions, but with a cost. They yield nuclear waste, which I'll get to later on. Currently, fission is the only working type of reactor in use today. Fusion generators require vast amounts of power, as fusing hydrogens into helium requires high temperatures and pressure, just like in the center of the sun. Countries such as the United States, China, and Germany are putting efforts into the development of a fusion reactor that will generate more power than it takes to run. Either way, both fission and fusion reactors use the released heat to spin turbines with steam that powers an electrical generator, just like most other sources of power. A 1,000 megawatt nuclear fission reactor only requires 27 tons of new fuel as compared to over 2.5 million tons of coal that a 1,000 megawatt coal plant would need. As the amount of fossil fuels decline, the coal plant is completely unsustainable. Uranium, on the other hand, is as common as zinc or tin in the Earth's crust, making a fission reactor far more sustainable. A fusion reaction uses hydrogen, which is only the most abundant element in the entire universe. A fission reaction of 1 kilogram of uranium yields 24 million kilowatt hours as compared to 8 kilowatt hours for 1 kilogram of coal. It is blatantly obvious that a nuclear plant can produce far more than a coal plant. Factor in a working fusion reactor, and it would be absurd to choose fossil fuels over nuclear energy. Nuclear energy research and development is slowed by the stigma of nuclear meltdowns. 3 key incidents make up the trifecta against nuclear plants: 3 Mile Island in 1979, Chernobyl in 1986, and Fukushima in 2011. The thing about 3 Mile Island is there were no long-term health effects or serious complications from the semi-meltdown of the reactor. Several system failures resulted in the meltdown, but as a result, legislation was passed that increased the safety of plants. Chernobyl was a complete failure due to the faulty design by the Soviets and the lack of proper training of power plant operators. This compounded into a complete meltdown of one of 4 reactors, causing thousands of people to be relocated. The Chernobyl disaster is a perfect example of how not to run a nuclear power plant. Fukushima was an unfortunate accident that resulted from the terrible earthquake and tsunami that hit Japan in 2011. While the situation was handled well by the Japanese government, the disaster still is indicative of a need for continued research into how to effectively prevent nuclear meltdowns in any case. As I mentioned earlier, nuclear waste is a problem associated with nuclear energy. In the case of fusion, the radioactive materials released decay incredibly fast, to the point where they are not a problem. Fission, though, creates high-level radioactive waste, which amounts to approximately 3% of the total waste produced by nuclear fission. It is this percentage that is the problem with nuclear energy, as parts of this waste can take hundreds of thousands of years to decay. But there are some solutions. Reprocessing can reuse up to 96% of the high-level nuclear waste, leaving waste that takes only 9,000 years to decay, rather than 300,000. Increased usage of this method would help fight the problem with storing radioactive material. For the parts that can't be reused, storage in deep storage centers in the middle of the desert are potentially viable methods, although more research on potential effects on the environment are necessary. Or, if you have plenty of money lying around, feel free to launch that waste into the sun for us. Let's get real for a second, though. As long as the stigma against nuclear energy remains, the world still faces a potential dark age. We need education for people and funding for research, so that one day we can enjoy clean, efficient energy across the planet. Tell family, friends, and your congressman about the benefits of nuclear energy. Together, we can advocate for nuclear energy and secure a future with sustainable sources of power. Thank you for watching, and feel free to ask us any questions you may have in the comments below.